Okay, conjecture number 62, proportional parts conjecture. It states, if two triangles are similar, then the lengths of their corresponding altitudes, medians, and angle bisectors are proportional to the lengths of the corresponding sides. So we have triangles ABC is similar to triangle DEF, and they're in a similarity ratio of 1 to 2, meaning this triangle is half the size of this larger triangle here. I've also gone ahead and measured the medians, the angle bisectors, and the altitudes for both sets of triangles. If I find the ratio for the medians, the angle bisectors, and the altitudes, they should all be the same as this original similarity ratio of 1 to 2. So if I come up and go to number and calculate, if I divide the two medians, I'll see that they're in a ratio of 1 to 2. If I divide the two angle bisectors, you'll see that they're in a ratio of 1 to 2. And lastly, if I divide the two altitudes, you'll see that they're in a ratio of 1 to 2. And as the triangles are moved here, you can see those ratios will maintain. Conjecture 63, angle bisector opposite side conjecture. A bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as the lengths of the two sides forming the angle. So we have triangle AB and C. I've measured the lengths of the two sides forming the angle that's bisected, and then I've also gone ahead and measured the opposite side and what it's divided into. So I have the measurement of segment AD, and this should read the measurement of segment CD. So I'm actually going to highlight this and delete it, and we are going to measure the length of segment CD. And what we're going to find when we calculate our ratios is the ratio of the sides forming the angle will be the same as the ratio that the opposite side is divided into. So no matter how the triangle is moved, those ratios maintain. Conjecture number 64, the parallel proportionality conjecture. If a line parallel to one side of a triangle passes through the other two sides, then it divides the other two sides proportionally. Conversely, if a line cuts two sides of a triangle proportionally, then it is parallel to the third side. So what we have here is I've measured the lengths from A to B and B to C. I've measured the lengths from A to D and then D to E. What you have here is you have segment BD parallel to the third side, side CE. What we want to show is that this parallel line divides the two sides proportionally. So if I come up here and calculate my ratios, so AB is to BC as AD is to DE. Okay, and no matter how this line moves, you'll see the ratio changes, but the ratios will always be congruent. The same holds true if we add another or several more parallel lines. Conjecture 65. Extended parallel proportionality conjecture. If two or more lines pass through the two sides of a triangle parallel to the third side, then they divide the two sides proportionally. So what we're going to do is we're just going to compare any two segments. So if I compare segment AB to BC, that would correspond with segments AE and EF. So number calculate, I would do AB is to BC, and we want to show that that's the same ratio as AE is to EF. And you can see those ratios are the same. And again, I can pick any two segments. I can say BC is to CD as EF is to FG. And you can see that those ratios would be the same. So even though the ratios are changing, you're seeing that these corresponding ratios are congruent, or proportional, I should say. And that's it for chapter 7.